Good afternoon, everyone. We'll get started. Today we'll be taking a look at Forane 516a, which is a very low GWP R-134a replacement refrigerant. I'm Kris Crosby. I'm with Arkema. I work in our R&D group out of the U.S. and primarily focused on refrigerants for HVAC and refrigeration applications. So the agenda for today, we'll take a look at Forane 516a refrigerant, some of the basic fluid properties of the product. Then we'll move into the simulated performance results that we've seen from the product, as well as some actual system drop-in testing and application testing in heat pumps and chillers. Finally, we'll move into material compatibility testing that we've completed, along with the TWE analysis, and we'll wrap it up with some conclusions at the end. So let's get started. Again, we're talking about Forane 516a refrigerant, which is a very low GWP R-134a replacement refrigerant. Here we have some basic properties of the product. If you look to the right-hand side of the slide, you'll see the composition of the refrigerant. It is a three-component blend of products. It's comprised of 1234yf, R-152a, and R-134a. It is a azeotrope, so it has no glide, and it is an A2L mildly flammable product. If you look at the GWP, it's 142. As compared to 134a, that's a 90% reduction in GWP. It is a design-compatible alternative to 134a, so it can be used in many 134a systems with very few modifications, and it can be used in very many different applications. So hopefully you guys can hear me over this music. I was not expecting that in my presentation, but a nice background, I guess. So here are some of the 134a and other alternative refrigerant properties if you compare this to other products. So there are a few products that really stick out in this table when you take a look at it. R-134a, of course, is the baseline. And as you look across the different products, the only other product that is an A1 refrigerant is R-513a, which is oftentimes used to replace 134a. However, it does still have a GWP of 631, so it may not be low enough GWP for the long run. And this is where R516A really comes in and stands out. You get below 150 GWP at 142, and you have properties that very closely match 134A. And again, we consider this a design-compatible alternative, so it can be used in many applications with very few modifications. And you can see on the right side the pressure temperature data as a comparison of these products. And 516A very closely matches 134A, and you can see the other refrigerants as well that compare. So when we looked at the thermodynamic cycle performance of the refrigerant, this is simulated performance through a ref prop or cycle D. And both 516A and 134A showed comparable COP and capacity to 134A, while pure R-1234yf showed a 5% drop in performance. So the chart on the left is the capacity and COP, as I mentioned, of the three products simulated. And you can see that 516A offers very close performance to 134A. On the other two charts, you see the compression ratio of the different products, along with the discharge temperature of the refrigerant. And again, you can see that 516A is lower in both of these cases, as are most of the other HFO products. So you do typically get a lower compression ratio and then also favorable discharge temperature with any of these products. So the next topic to discuss is actual system testing. So this is a drop-in test that we performed in our R&D lab, where we took an off-the-shelf closed-door refrigerator unit, what we call a beverage chiller, which has the refrigeration unit on the top of the case, and we drop-in tested 516A in this application instead of the 134A that came in this unit from the factory. This was an off-the-shelf unit that we purchased and did this testing with. And all of the refrigerants that we tested were drop-in tested with very minor changes to the system, primarily just TXV adjustments to control the superheat per the manufacturer's recommendations. So the experimental results that we saw at a temperature of around 24 degrees C, we see that the compressor total runtime and compressor power consumption on the left, R-516A, showed favorable results to similar results to 134A and favorable results compared to 1234YF. The middle chart is showing the energy consumption relative to 134A. So one of the big advantages that we're seeing with 516A is that it does consume less energy than the alternatives, primarily driven by reduced runtime of the compressor. So we're seeing less energy consumption than 134A and substantially less than 1234YF standalone. And on the right, we can see the cycle times of the various different refrigerants. So looking at all of these, we can see that R-516A really performed the best when it came to energy consumption. And again, on the previous slide, we showed the favorable discharge temperatures in simulation. This was also verified through this testing. So here we've repeated this same test at a temperature of 32 degrees Celsius. And again, the results are very similar. So we see R-516A with very similar performance to 134A on both compressor runtime as well as compressor power consumption. And then when we look at the total energy consumption and compare that to 134A, again, we see that 516A is really the standout performer of these refrigerants, outperforming 134A and substantially outperforming R-1234YF. So one of the applications that we've looked at specifically for 516A is heat pumps. Of course, we're hearing more and more about heat pumps across the globe, and they're becoming more and more mainstream in many heating applications. So this product performs very well in heat pump applications. And we worked with an industry partner, Danfoss, on this project, where we were testing the refrigerant and oil-free centrifugal compressor, a technology that they've been working on, which offers 30 to 50% energy reduction when compared to conventional compressors. So at the 2021 Heat Pump Conference, we presented a joint paper with Danfoss on R-516A, showing the performance results that we saw when this was tested. So as we can see in these charts, R-516A showed comparable performance and compressor speed compared to 134A, and it exhibited significantly lower discharge temperatures, which helped broaden the operation map of the compressors. So very good results in this application. The next application I would like to discuss is R-516A in chillers. Again, we worked with an industry partner on this project to evaluate 516A in medium pressure chillers. This was a 370 kilowatt air-cooled 134A screw chiller drop-in test. And again, these results were presented at a previous ASHRAE conference. And we can see from these charts, again, the performance is very close to 134A. Really almost identical in both of these ambient conditions. Of course, with any new refrigerant that's being evaluated, you have to look at the material compatibility of the product. So this product is made up of 3 components that are very common components that have been used, and none of those have any massive material compatibility issues. So we wouldn't expect to see any material compatibility issues with this blend. However, you still do have to do this evaluation. So we've been participating in the AHRTI 9016 material compatibility study, and the results that we've seen so far have shown good material compatibility. Some of the photos from that testing are shown here, and we really saw no compatibility issues with any of these materials. This testing is ongoing, so it's not complete. This project is continuing, and the next phase is preparing to start at this time. Again, we don't expect any material compatibility issues, but that will be completed in the coming year. Next, we will talk about the total equivalent warming impact with 516A or TWE. We won't go into the details on how these calculations are done. This is a standard method of calculating the total equivalent warming impact. But what this really does is take into account the direct and indirect emissions associated with the product. So rather than just looking at straight GWP, it takes a look at the GWP, but also the indirect emissions of the product. And when you look at this as a whole, R516A really stands out amongst these alternatives and when compared to 134A. So it has the lowest total equivalent warming impact of any of these products. Of course, that's driven by the low GWP at 142, but also driven by the energy efficiency gains that you see with the product. So definitely very promising results. So in conclusion, Forane 516A is a very ideal low GWP replacement for 134A that is design compatible, so it's very easily used in many 134 applications with very few design changes that have to be made. It offers better performance than other low GWP alternatives such as 1234YF. And it can be used in many applications, as I mentioned, heat pumps, chillers, and refrigeration, amongst others. So really any application that currently uses 134A today, it can perform very well. We've seen very good material compatibility results, and we don't expect any issues there. And then, of course, it has the low total equivalent warming impact when compared to the alternatives that are being proposed. So thank you. I appreciate your time. If anyone has any questions, feel free to reach out to me. You can also stop by the Arkema booth in Hall 9, and we would be more than happy to discuss this product with you. Thank you.